Morning students, today I am with the topic number of diagonals in a polygon. First of all, what do you mean by diagonal? Diagonal means a line segment that joins two vertices of a polygon. But which kind of vertex? Two non-adjacent vertices, not adjacent vertices, two non-adjacent vertices. For example, I am drawing here a pentagon. You see, suppose this is vertex number 1, vertex number 2, vertex number 3, vertex number 4, vertex number 5. Already vertex number 1 and 2 are joined. This is called side. This is called side. Vertex number 1 and 5 are joined. This is called side. When I join vertex number 1 to 4 or vertex number 1 to 3, this line segment, this is called a diagonal. Okay. It is a convex polygon, so diagonals are inside. But in case of a concave polygon, for example, I will draw a pentagon like this. This is also a pentagon. 5 sides are there. 1, 2, 3, 4, 5. In this case, vertex number 1, 2, 3, 4, 5. If I join 1 and 3, you can see that this line segment is coming outside the polygon. This is a diagonal. It is joining two vertices which are not adjacent. Okay. So this is a diagonal and it is coming outside. If I join 3 and 5, this may be partially outside and partially inside. So in case of concave polygon, the diagonals may be partially inside or outside or completely outside. Is that clear? But here this is a convex polygon. In convex polygon, we will have all the diagonals inside the polygon. Is that clear? Now you see here, I can join 1 and 3, 1 and 4. If I take vertex, here I do 1. Now if I take vertex number 5, 5 and 1 are joined, that is called a side. 5 and 4 are joined with a line segment, this is called a side. But when I join 5 to 3, this is called a diagonal. 5 with 2, this is called a diagonal. Okay, so from each vertex I am able to do two diagonals. You can see from 1 I drew this diagonal and this one, two diagonals. From 5 I have drawn to 3, from 5 to 2. These are two diagonals. From 4 already one diagonal is here. When we drew from 1 to 4, this diagonal, that is counted for vertex 4 also. So from vertex 4 I can draw only one diagonal right now. That will be from 4 to 2. Okay, this is the second diagonal that you can draw from 4 to 2. 4 to 1 already drawn when you drew it from 1 to 4. Is that clear? Now from 3, do you find all the diagonals are drawn? Yes. From 3 to 5 already we have a line segment joining them. 3 to 1 already we have a line segment joining them. There from 3 we have two diagonals drawn already. Now you check from every vertex the number of diagonals are drawn completely or anything is left. Nothing is left. All diagonals we have drawn. Can we count? Yes. 1, this is 2, this is 3, this is 4 and this is 5. But in case of bigger figures, drawing diagonals and counting them will be quite difficult. We can instead have a formula for finding number of diagonals. Will that not be a better idea? Yes, that is. So let me just observe this. How can we have a formula? Okay, let's find out. I will take the number of vertices of a polygon as n. Here how many vertices are there? 5 vertices are there. Alright. Now to how many vertices you could draw diagonals? Out of 5 vertices, let us say from vertex number 1, you are able to draw diagonals to only 2 vertices. They are 4 and 3, but not to 2 and 5. You know why not to 2 and 5? When 1 is joined to 2, 1 is joined to 5, you get sides, not diagonals. But when you join 1 to 4, 1 to 3, vertex number 1 to vertex number 3, you get diagonals according to definition of diagonal, right? So you are not able to draw diagonals to how many vertices from each vertex? You are not able to draw diagonals from a vertex to its adjacent vertices. You are able to draw to non-adjacent vertices. How many adjacent vertices are there? 1, 2. 2 adjacent vertices for every vertex. We are taking example of vertex 1 here. So for vertex 1, adjacent vertices are vertex 2 and vertex 5. You cannot draw diagonals to them. And at the same time, the vertex itself cannot be joined with the same vertex to get a diagonal. So 1, 2, 3 out of 5 vertices, out of total number of vertices, you are not able to draw to 3 vertices diagonals. Here if you pick up vertex number 1 as your vertex, then from vertex 1 you were not able to draw diagonal to 2, and you are not able to draw diagonal from 1 to 5, and you are not able to draw diagonal from vertex number 1 to vertex number 1 itself. So 3 vertices, you are unable to draw diagonals to 3 vertices. So to how many vertices you will be able to draw diagonals? N minus 3 means 2 vertices here. Okay, n is 5 minus 3, 2 vertices. Now how many total number of diagonals we are going to calculate? We are going to find out a formula for that. So let me tell you. Now you came to know that to this many vertices, to n minus 3 vertices, you can draw diagonals. How many vertices are there? 5 vertices are there. So from each vertex you can draw 2 diagonals. N minus 3 is 2, number of vertices is 5, 5 2s are 10. So 10 diagonals it says. But are we having 10 diagonals here? You can see we had 5 diagonals, correct? We had 5 diagonals here. So draw one diagonal from 1 to 4, the same diagonal runs from 4 to 1. So when you are counting number of diagonals drawn from each vertex, suppose from vertex number 1 you counted diagonal 1, diagonal 2, 2 diagonals. Okay. Now similarly when you go for vertex number 4, at that time you will again count 2 diagonals. As we calculated, from each vertex 2 diagonals can be drawn. So for you this is one diagonal, this is one diagonal. You will count this diagonal which you counted already for vertex number 1 again, and that will give you double the number of diagonals if you go on counting like that. Am I right? Every diagonal will be counted 2 times, okay, in this whole process. That's why you are getting double of diagonals. 5 diagonals are there, but you're getting 10 when you multiply this. So our formula becomes n multiplied with this by 2. Okay. So number of diagonals will be n into n minus 3. This gives you actually 10 by dividing by 2. Why we are dividing by 2? Because as I said, from vertex 1 the diagonal which runs, the same diagonal runs from vertex from 4 to 1, vertex 4 to 1. So that's why I have divided with 2. So that's why the formula for number of diagonals is this. Now you can calculate the number of diagonals for quadrilateral, hexagon, and any other pentagon, any other polygon also. I can show you by drawing. It will be a beautiful diagram when you draw. See, for hexagon I am drawing 1. This is vertex number 1. This is 2. This is 3. This is 4. This is 5. This is 6. Now I am drawing the diagonals inside. From vertex number 1, how many diagonals I can draw? Now you can tell me clearly. For vertex number 1, 6 and 2 are adjacent vertices. You cannot draw diagonals to adjacent vertices. Non-adjacent vertices, how many non-adjacent vertices are there? 1, 2, 3. 3, 4, 5 are non-adjacent vertices for vertex number 1. You can draw diagonals to them as I have drawn. Now if you start doing it for vertex number 2, 3, 4, 5 and 6, you will be able to draw all the diagonals. Am I right? Let me complete it. For vertex number 2, this, and this. Vertex number 4, 5, 6 non-adjacent. I have drawn diagonals. For vertex number 3, 1, 6 and 5 are non-adjacent. But when you drew diagonals for 1, it joined to 3 already, and that same diagonal runs from 3 to 1. So already you are getting one diagonal. 2 diagonals you can draw more for 3. That is joining vertex 5 and vertex number 6. This and this. Now from vertex 4 already you are having 2 diagonals, joining 2, joining 1. Because when you consider vertex number 1 and 2, at that time you had joined already to 4 to get diagonal. So the same diagonal runs from 4 to 1 and 2. That's why you don't have to count them again. You are left with one diagonal that will be drawn from 4 to 6. This. And from 5 already you have 3 diagonals drawn. Can you count this? Yes, here also you can count probably. There are 9 diagonals. Using this formula, we can calculate that number of diagonals. See, n stands for number of sides. For hexagon, n is equal to 6. Now, number of diagonals will be n into n minus 3 by 2. That means n means 6 and 6 minus 3 by 2. This gives you 6 into 6 minus 3 is 3 by 2. So you get 2 3 is 6, 3 3 is 9. There are 9 diagonals. Hope you are clear. I can show you for quadrilateral also. You know, quadrilateral has 2 diagonals. We can verify it with our formula also. N is equal to here how many? Tell me. Number of sides 4. In case of hexagon, number of sides were 6. Here number of sides are 4. N is 4. Number of diagonals, let's use our formula. N into n minus 3 by 2. So n means 4. 4 minus 3 by 2. So I get 4. 4 minus 3 is 1 by 2. So 4 by 2. 4 into 1 is 4. 4 by 2 gives you 2. 2 diagonals. In the similar manner, you can find out the number of diagonals for any polygon if you know the number of sides or number of vertices. Number of sides is equal to number of vertices in a polygon. So you can say number of n means number of sides or number of vertices. At the same time, let me make one thing clear here. Here while writing, I must mention you for your clarity, n stands for number of vertices or number of sides. Here n minus 3 was giving you what? Number of diagonals from each vertex. Each vertex. This is given by n minus 3. N minus 3. In case of pentagon, n minus 3 was 2. So from each vertex you can draw 2 diagonals. In case of hexagon, from each vertex you were able to draw 3 diagonals. Am I right? So you can now find out number of diagonals for any polygon. So tell me in the comment section how many diagonals does a 15gon has. 15gon means a polygon with 15 sides. What formula you learned today? The formula for number of diagonals is, let me erase it and write here once again for you. Number of diagonals in a polygon is equal to n into n minus 3 by 2. This is formula. Remember it? In my next class, I'll be with some other concept. Thank you for now. Keep watching my videos. Thank you.